we don't know how to do it. You would need very smart systems that are much more reliable than what we have to really underwrite the agents that people want right now. And so we're getting like a sneak preview of the future, but it'd be like getting a sneak preview of a car in 1850 and, 1 in 4 of them blows up in your face. And it's like, you should probably wait on let somebody else test drive those things, and they'll learn that gasoline is explosive and that, maybe you shouldn't be in the vehicle when you fuel it and stuff like that, which like people eventually learned in boats. And Apple actually had in their system prompt about a year ago, maybe still do, told the systems, be truthful, don't make stuff up.
Yeah.
Don't hallucinate. And then they did anyway, right? That's a simple version of alignment. Like, I'm going to tell you, like, don't make stuff up. And I could tell that to, an intern working for me, an employee. And if I told that to an employee who was working for me and they kept doing it, they'd be gone.
Exactly.
Right? But LLMs, instead of being gone, we're giving them another $500 billion in funding. It's kind of insane.
Hey everyone, David Bombal coming to you from Black Hat with a very, very special guest. Gary, welcome.
Thanks for having me.
Great to meet you. My team have been telling me so much about what you've been sharing, and I've been like watching your videos and stuff. So happy to have you on the show, giving us a reality check about AI. But before we even get there, something big has just dropped.
That's right. Just minutes literally before I came, GPT-5, OpenAI dropped GPT-5. They did a public announcement of GPT-5. And I have to say, for most people, it's probably disappointing. People have been talking about GPT-5 since GPT-4 came out. That was 32 months ago. And in fact, Bill Gates saw a preview of GPT-4 4 years ago, if I have my math correctly. No, 3 years ago, three full years ago. And ever since then, people have been like, wow, GPT-5 is going to be amazing. In fact, I just tweeted about it, a picture with Kevin Scott, who's Microsoft's CTO, with a little picture of GPT-3 as some tiny little sea creature. I guess it's a tiny little whale. And then GPT-4 is a little bigger, but noticeably bigger. And then GPT-5 in this diagram that Kevin Scott did about a year ago is this giant humpback whale. And what I've been saying all along is it's not really going to be this great humpback whale. It's going to be like the other systems, a little bit better, but not hugely better. And that's kind of what we saw. GPT-5 is better on many benchmarks. The biggest thing about today's presentation, they already got nailed at minutes into the presentation, which is they showed all these benchmarks and they say, we're better on this, we're better than that. Sam Altman says this is the smartest model of all time. But they didn't report Francois Chollet's ARC AGI-2, which is a benchmark a lot of people pay attention to, and that they paid attention to in their O3 demo 6 months ago. Didn't mention it. Well, guess what? It doesn't even beat Grok 4, which came out a month or two ago. So we have this story we keep hearing about exponential progress. Yep. Somebody I know vaguely from Twitter posted today, I don't want to hear about exponential progress anymore. And this is someone who was enthusiastic and kind of believing the hype, and has become disillusioned. And I think a lot of people are slowly realizing that they've been sold a bill of goods. Like, it's one thing to say each model is going to be a little bit better than the last. Well, of course it's going to be. You spent $1 billion on the model. You should get some return on your investment. You should hope so. But that doesn't mean that these things are AGI, artificial general intelligence. This new model, definitely not AGI. Can't even beat Grok on this one test. There's incremental progress here. There is nothing like this giant humpback whale leap that we've been promised.
Big thanks to Brilliant for sponsoring this video. Have you got a crazy schedule but want to learn something new every day? Well, I've got an app for that, and that's the Brilliant platform. You can have access to the Brilliant platform by installing an app on your phone, which gives you the freedom to study wherever you are. Doesn't matter if you're commuting on the train or if you just have a few minutes downtime, the Brilliant app allows you to learn something in bite-sized intervals when you've only got a few minutes of downtime. Don't just look at mindless content where you won't even remember what you've looked at tomorrow. Rather, spend your time learning something. But it's also really important to be consistent in your learning. Learn a little bit every day, and Brilliant can help you with this, with their app. As an example, you can build your Python programming skills with a Python with Functions course. You start with the basics, a quick introduction to functions, and then you'll learn about tuples or tuples if you prefer, how to debug functions, what function dependency is, and how you should compose a function. You'll even learn about multiple inputs for a function. And then Brilliant challenges you to go further so that you can hit those big learning goals one day at a time. And there you go, consistent learning or locked in with an app on your phone. If you want to try everything Brilliant has to offer, go to brilliant.org/David Bombal, or you can scan the QR code on screen. You'll also get 20% off an annual premium subscription. Make sure that you use my link in the video description and start learning something new today. Education changes lives. You can change your life by just studying a little bit every day.
Yeah, because I keep hearing the hype, right? AI this, AI that. Everyone's got AI on every product. But, it seems just to be a lot of hype a lot of the time.
I mean, there's real progress. So, systems today are definitely better than systems 3 years ago. But the hype is like, this is going to solve all your problems. Reality is there are some context for it. I mean, what we learned at this conference is that the biggest context for it, which is coding, actually has huge flaws. So for the last year, everybody's been talking about agents and how great they're going to be. And I kept saying, come on, hold your horses. They're going to be flawed because they have multiple steps. Every individual step within an LLM is actually a risk something's going to go wrong. So you put them together, you have serious problems. And there were 2 talks here, one from NVIDIA, another this morning from Nathan Hamill, showing that these things called prompt injection attacks make these systems like total sitting ducks. So if you use one of these so-called level 3 agents, as NVIDIA's terminology is, it writes code, it goes out in the web, it looks for examples. And those examples, I think they call them like watering wells or something like that, are just filled or can be filled with bad code that does terrible things. So they show basically or not quite live demos, but recordings of demos where they would ask a system to create this bit of code. And next thing you know, someone basically had control of their system, remote code execution, which is basically the worst thing that can happen to you, right? And they showed not one, but like a dozen different ways to do this. And each of those ways is actually some huge attack surface. So, essentially any code that you can get the systems to absorb becomes an attack surface. And so those are huge problems here. One way to think about it is we want our AI to be safe and secure, helpful, and so forth. That means we want to be able to instruct it. We don't want to tell it stuff. So the funniest, in an ironic, dark sense, dark humor funniest thing in this talk is somebody put in one of the, basically a system prompt, user prompt for the coding, they put in only write secure code. The system has no idea what that actually means, right? It's like when you tell the system to do this bank transaction for me and it says I'm on it and it doesn't actually know your passwords and so it can't do it, right? It's just spouting things that people say, if you asked it, are you writing secure code? It might say that it is, but the reality is it's not. It doesn't have a deep enough conceptual understanding of what secure code is. And the same is true in any domain. So we've seen it delete people's databases and all that.
Yeah, I'm glad you mentioned that because we had Black Hat. And I mean, my big concern with this is the cybersecurity piece. So I'm glad you mentioned agents because if you've got agents supposedly doing everything autonomously, they're not writing secure code. I mean, it's an attacker's paradise.
Maybe 20 years from now, agents will write really great code that'll be much better than humans. But we're going to be in a transitional period for a while where agents are going to write shit code that is not really secure, is not as good as the best coders can do. Partly because the best coders aren't taking everything off random repositories that they don't understand, and they understand the code that they're using if they're good. I mean, bad coders have always been a problem, but good coders have a conceptual understanding of, what a memory overflow error is, and they look at some piece of obfuscated code. They're like, I'm not putting that in. I don't know what that does. It looks like a bunch of digits because it's, been obfuscated, and they know better than to use the code. But these agent systems don't really know what to use. And so they're sprinkled with so many vulnerabilities. And if you use these systems only to say, hey, what's a way I could write a piece of code for some small little thing? Like, I want to learn how to translate this into bold in Unicode, right? You can look that up. You could have looked it up on Stack Overflow before. Now you can use ChatGPT or Claude or whatever to find that piece of code for you. That's fine. That's not what I mean by full agency. Full agency is like, I have bug reports on my code. Go fix them. That's not me finding one little piece of code that I, with my human eyes, can check out. That's like leaving the system with a lot of autonomy. And it's really when that autonomy comes in that you have problems. I know you were just interviewing, I want to get his name right, Mikko Hypponen I saw his talk yesterday, and what's the title of his book? Something like if you make it smart, it's going to be vulnerable, or something like that.
If it's smart, it's vulnerable. Yeah.
If it's smart, it's vulnerable. Well, that is true in spades with an asterisk in this situation. These things are not really smart, but the given powers, right? It's really if it's autonomous, it becomes vulnerable. And some of the vulnerability comes from stupidity. So it doesn't understand, for example, that if somebody writes something in white on white text, that's probably actually bad news. They probably did it to conceal it from your system, right? They don't really understand that. And, people will add Band-Aids to this and to that, but there's so many ways to attack code. So if you're talking about my code, because I write a video game to amuse my kids, probably nobody's going to go after me. But if you're talking about, Defense Department stuff or whatever, then somebody wants to get in. They're going to be able to find many ways to get in. I mean, it was already the state of cybersecurity, as you well know, was not great, that it's going to get much, much worse as a result of this.
Yeah, I mean, you mentioned agents, but I'm assuming you're also talking about vibe coding. That's all we're talking about,
so
right?
The vibe coding uses agents. So I mean, vibe coding is basically subject to this. People use different tools, and when they're doing this vibe coding stuff, they've got some agent in the background with some degree of autonomy.
Yeah.
One of the things that was mentioned in the NVIDIA talk was there's actually something you can switch off called auto install, or I forget what the name of the option is, but basically you have the system write code, and like if it's a package, it downloads it, runs the code for you. And that's probably the worst thing. And now like the people making vibe coding platforms are like at least giving you an option to turn it off, or maybe for your whole company. But what happens is we're in Vegas, it's a little bit like slot machines. It's like people will just keep pulling the handle, and they're just going to keep looking. So even if that option is switched off, they're going to get a lot of like, do you want to install this package? And their eyes are going to glaze over. They want to move fast because coders get rewarded for how much code and so they're going to end up installing these packages anyway, whether it's auto installed or not. And it's when you install code from the outside that you don't understand. There was another example where there was code in a comment, and it was like hidden to the right of the screen. And so like the user's not even going to notice this code off on the right of the screen. They're looking here and it's over there. Like so much stuff is going to filter in. And yes, a lot of that is in the vibe coding context.
Yeah, I mean, it just seems amazing that they want to give so much power to agents to run our lives. And so I've got to ask you this question,
We're
right?
just not ready for that.
Yeah.
Like it's something we should aspire to, I suppose. Like, someday we will want that. I mean, just like, instead of hiring somebody, if I can just do this, then, it saves money. Maybe it's faster. I don't have to worry about what time zone they're in. Like, there are reasons why you might want this. But the problem is the only way we know how to build these things right now is with LLMs. And large language models are inherently flawed. They hallucinate. They make weird errors of reasoning. I mean, imagine if they hallucinate code. And in fact, some people are looking into that as a vulnerability. Like, you can guess what the hallucinations will be. Instead of putting the offending code in the clear, you put code that's similar enough that there will be a hallucination that will be the thing that you want. How are you going to defend against that? We don't know how to do it. You would need very smart systems that are much more reliable than what we have to really underwrite the agents that people want right now. And so we're getting like a sneak preview of the future, but it'd be like getting a sneak preview of a car in 1850 and, 1 in 4 of them blows up in your face. And it's like, you should probably wait let somebody else test drive those things, and they'll learn that gasoline is explosive, and that, maybe you shouldn't be in the vehicle when you fuel it and stuff like that, which like people eventually learned in boats. We're at such early days, and there are dangers. And the dangers here are not that anybody's directly going to die, but people may indirectly die because you have, bad code that controls an electrical grid or nuclear grid or whatever. And then, databases are getting deleted, or they get, rewritten with who knows what, or information will, travel to our enemies and so forth. So there are a lot of real dangers, even if it's not a perfect analogy to a car explosion. There's going to be lots of problems.
Now, you mentioned the word hallucinations. Didn't you mention that in your book?
Yeah, I actually think I kind of came up with the idea of hallucination. This is my 2001 book, The Algebraic Mind, and I really think I laid out most of what we're facing right now in terms of what are the challenges to a neural network approach. So I was working with earlier neural networks in my dissertation, and this kind of grew out of my dissertation. My dissertation was about 8 years earlier, but it grew out of explorations of the neural networks that people were building back in those days. And I did experiments on them and found kind of problems with them. And there's this one little passage that really anticipated hallucinations. I gave this example of my Aunt Esther winning the lottery, or I wish that she had, but so in the hypothetical, my Aunt Esther wins the lottery, and then I teach that to this neural network, but the neural network erroneously generalized the winning of the lottery to 11 of the remaining 15 people that sort of shared some properties with my master. And so I went on to say, this kind of overgeneralization is the inevitable downside of the kind of automatic generalization that we're talking about here. That was basically in 2001 pointing out the problem of hallucinations and saying it's inevitable, and as long as we're doing this and not something else, and we can talk about what the something else.
Yeah, I'd like you to, because my question is like, why do LLMs hallucinate?
So they hallucinate because of what I'm talking about, automatic overgeneralization. I guess I haven't spelled it out clearly enough, but what they were doing and what we still do is we have what we call distributed representation. So instead of having a single database record, let's say, for each individual person, and then facts about those people, what neural networks do, and it helps them when it helps them, but it hurts them when it hurts them, so to speak, is it breaks all the information into little bits of information. So in this particular system, there was no unique node for my Aunt Esther, but rather Aunt Esther is coded as the properties that she shares with other people. So things work a little differently now, but we talk about embeddings and embedding spaces and so forth. And so what you'll find is like a bunch of people that share properties are put in a similar place, and then the system guesses that things that might be true of that cluster of people might be true in general. In a recent Substack, I talked about my friend Harry Shearer, who you might know. He does the voices for a bunch of the Simpsons characters. He was the bass player in The Simpsons. He's been in a bunch of movies. He's been in a bunch of movies, for example, with Christopher Guest, who's also in Spinal Tap and so forth. And so the system, somebody sent a biography to Harry, which he sent to me, said that Harry Shearer was a British entertainer, voice actor, etc. But he's not. He's American. He's born in Los Angeles. And so he thought this was funny. Then it went on to say that he was in the movie, or he helped do voices for Jaws, which he didn't really do. And it said a bunch of things were true. And it got the name of his character wrong. And so, like, some of it was true.
You had a chicken, right?
Well, there's a story about me, and somebody sent me a biography of me. I don't sit there asking for biographies from ChatGPT because I think they're worthless. But somebody else did a biography of me. They sent it to me, and it said that I owned a pet chicken named Henrietta. I don't own a pet chicken. If I did, I wouldn't call it Henrietta. And so this has become kind of a running joke. And in fact, that's why Harry Shearer sent it to me. In fact, the title line before he passed someone else's message with the biography was "No Henrietta, but still." That's what Harry wrote it in his message. So alluding to my famous, hallucinatory chicken named Henrietta. So this has been a consistent problem going back to 2001. And what really kind of irritates me about the kind of hypey people in this field is they're always saying, yeah, wait till next year. We'll solve it next year. And I'm like, dude, you've been telling me that for a quarter century, and your approach does not work. It still has this problem. Today's models did a little better on some benchmarks with hallucinations, but it's still like 3%. I mean, like, making stuff up like 1 in 30 times is really not good. Stuff that you can easily get out of Wikipedia and databases. I mean, we're not talking about making stuff up in some, really obscure thing, but also if you're making it up, you should say so, right? A good AI system, and this comes back to agents, should say what it doesn't understand. And so it should either say Harry Shearer was born in Los Angeles, which is not hard to find, right? You can find that in Wikipedia on the front page of his entry, the first page of his entry. Like, either it should give you that, or at least it should say, I don't know, or it should say, for some reason, I feel like telling you London, but I can't bear that out, right? Everybody imagines LLMs to be intelligent like other humans, and they're not. They're doing something different. They're doing autocomplete. I actually coined the phrase autocomplete on steroids a number of years ago. They're doing autocomplete on steroids, and that's just what they do. And they don't do fact-checking. They can't get a job at the New Yorker doing fact-checking. That's not what they do.
Artificial intelligence, it's supposed to be some kind of intelligence, but AIs aren't intelligent. Is that right to say?
That's a definitional thing. So, you could say that a chess computer, although actually, I don't know about GPT-5, but 3 still has problems with chess. We'll get to in a second, maybe. You could say a chess computer has a measure of intelligence, because you could say intelligence is multidimensional. There are many aspects of it. One is being able to do, the raw calculation in chess, and Garry Kasparov was really good at chess. He can do a lot of other things too. He's really good at politics, as well. But, a chess computer has a piece of intelligence. I would say no chess computer, even the one that beat Garry Kasparov, is remotely as intelligent as Kasparov, because Kasparov has this flexibility in how he can reason and think and so forth. I actually have a podcast coming out with him any day. We talked as fluently about politics as we did about AI and as we could have about chess. And we did talk a little bit about chess. his mind is versatile, and not everybody is Gary Kasparov. In fact, nobody is Gary Kasparov.
Exactly.
But even the average human being can actually fluidly think about a lot of things. So, for example, they might go to a Harry Potter movie or read a Harry Potter book and say, oh, there's this thing called Quidditch. And then they can learn about it, even though it doesn't happen in our world. You don't have a lot of experience with Quidditch before you watch or see Harry Potter because it's not a real world thing. But you start to understand, okay, well, they're flying around on the broomsticks and this might be possible. And this might, if I said, could you fly the broomstick in 1 minute from England to the United States? You'd say no. You can start to reason about it, even though it's a domain that's not familiar. And the current systems have a lot of trouble doing that. They might be able to do it with Quidditch because there's enough data about it. But if we came up with some other novel thing, they're going to have trouble with it.
So, will LLMs ever stop hallucinating? Because you said there's another way to do it, perhaps, or something.
Well, I think what we have to do, let's say, set them aside. I think LLMs have some value. They're really good at learning statistical distributions, and that's very useful. But they're not good at learning abstractions. They're not good at representing particular individual bits of information in a reliable way, like where is Harry Shearer from?
Yeah.
Now your listeners, having heard me say it a few times, can probably say Los Angeles, right? These systems can't reliably do that from, even like one of the reasons I used Harry Shearer as an example is he's famous, right? He's not as famous as Donald Trump, but he's pretty well known. And so there are many entries about him. There's Wikipedia and then IMDb, and, he's been in any number of like profiles and news. So there's a lot of data there, and still it doesn't stick. I meant to talk to you about chess, by the way, which is these models get trained on chess. They see lots of games. They see the rules of chess. They download sites like chess.com that teach you. And you can ask them a question like, can a queen jump over a knight? And they'll say no. And then in the course of a game, they'll actually have a queen jump over a knight. So they don't know what's an illegal move, right? They've been told it. They can have an explicit knowledge, but they can't act on it. And that's, this is the same problem I was talking about with the agent. You can say write secure code, but they can't really act on that.
Yeah, because you're saying it's like it's autocomplete on steroids. It doesn't
autocomplete on steroids. Yeah,
it doesn't seem to have intelligence in what it's doing.
Again, like to just nail that down. So there are aspects of intelligence that you could say it has, but it's certainly not like a complete, thorough intelligence. It's like, it's almost like we don't really use this term as much anymore, but an idiot savant that can like tell you what day a certain calendar day is. Which, by the way, one of these systems just messed up. A friend of mine asked what day like September 4th would be, and it got the wrong day, what day of the week, and got it wrong. But so, like an idiot savant, they can do certain things really well. In particular, statistical prediction of what is likely in a context. They do extremely well. But there are other things like fact checking that they can't do at all. And you would expect a real intelligence to be able, or a robust intelligence, let's say, to do it. So you could say, it's sort of like a bullshitter in, a bar, sophomore in college trying to fake their way through things. Like, it can convince the uninitiated, but, like anybody who looks in their field of expertise looks at it and is like, well, when it talks to me about physics, it doesn't really know about physics. And we have this illusion, well, I don't know any physics. It looks pretty good to me. But you ask an expert, and the expert's like, no, it doesn't actually understand physics. It can parrot back a bunch of things that are there, and they can train them on massive numbers of problems so it can solve problems of certain sorts. But the flexibility and generality of human intelligence, they really lack.
So are we going to see this diminishing returns? Because, companies are spending huge amounts of money throwing GPUs, data, whatever, at these things. We're not going to get this massive spring forward like we were supposed to get with GPT-5?
We are already getting diminishing returns. So, GPT-5 is better than GPT-4, but it's not massively better. It's measurably better, I would say, but it's not massively better. We are seeing a moment of diminishing returns. We're finding other techniques might help, one of which is to add classic symbolic techniques. So the whole history of AI has been that the neural network people and the symbolic people basically hated each other.
Yeah, can you explain that? Give us some details about that. Go on, Trey.
Yeah, so the neural networks are what's popular right now. They try to break bits of information into tiny little bits, get lots of statistical information, and do things like autocomplete. The symbolic stuff looks more like classical computer programs, like algebra, like logic, and we use those for certain things. Like GPS navigation systems use symbolic AI, all the time and use it very effectively. Because of fights over resources like graduate students and funding and stuff like that, the two groups have been really hostile to one another. And what I called for in this book, The Algebraic Mind, The subtitle was Integrating Connectionism and Cognitive Science. Connectionism and neural networks, and cognitive science was more the classic symbol manipulation stuff. That's what we need is some reconciliation, which I've been like begging the field to do for 25 years. And a little bit of it is kind of sneaking in the back door right now. They're starting to add some symbolic stuff into the large language models, which I think is a little bit too little, too late, but that's where the progress that they're actually getting is coming from.
So Gary, we had Black Hat again. I look at this from a cybersecurity point of view, but like, what about AI safety? What can you tell us about that?
I mean, obviously the related notions, right? So cybersecurity is really about like, is your code secure? Can somebody steal it? Can somebody control it? And there's like a commercial version of that. And then there's like a humanity version of that, which is like, is our species safe from what can be done with these systems? And there are different aspects. So for example, can these systems teach somebody how to build a biological weapon? Somebody who couldn't otherwise do it, teach them beyond what they could get from Google, and so forth. And the answer increasingly looks like it might be yes. There are these fears of so-called rogue AI. My view is we've made a lot more progress, not on artificial general intelligence, but at least some usable stuff, what we can do with autocomplete on steroids and so forth. We made real progress there, but on what we call alignment, getting the machine to do what we want to do, not so much. Like hallucinations is an example. Apple actually had in their system prompt about a year ago, maybe still do, told the systems, be truthful, don't make stuff up.
Yeah.
Don't hallucinate. And then they did anyway, right? That's a simple version of alignment. Like, I'm going to tell you, like, don't make stuff up. And I could tell that to, an intern working for me, an employee. And if I told that to an employee who was working for me and they kept doing it, they'd be gone.
Exactly.
Right? But LLMs, instead of being gone, we're giving them another $500 billion in funding. It's kind of insane. If you can't tell a system don't hallucinate, what about, like, don't cause harm to humans? Can you really get a system to understand that? And the answer is no. And there's been no major progress on that problem in, quarter century. You could argue that the biggest progress was made by Isaac Asimov, in the 1950s when he proposed, knowing that they weren't all that great, Asimov's laws, what we call it, he called them the 3 laws of robotics. They weren't that great because they don't cover all the situations and so forth. And that was part of the point of his stories is like, this is actually hard. But at least he raised the question of like, what ethical principles would you instill in a machine? He raised the right question. Asimov did. We still don't have an answer either to what you should actually code in, which is hard and, there are cultural issues and so forth. But we don't have an answer to that. And we don't have an answer to how to do that. Right? And, a bunch of people have worked on that, but they're all working on it in the LLM context. My view is LLMs are too thick. They're not semantically rich enough to be able to understand such concepts. And so, another way to put all of this is LLMs are black boxes. We put a bunch of data in and we get something out and we hope for the best. And that's basically how it works.
And we want to run the world on that.
We should not run the world on hope for the best. We should really be building white box AI where we understand what's in it so that we can debug it, right? We radically shifted to this black box way of doing things. Now we're writing code. Vibe coding is mostly, at some level, black box code. It's not literally because you can actually at least see its output, but from the perspective of many users, it basically is a black box. They don't understand the code that they've written or that they've had the machine write. And the LLMs themselves are black boxes. And it's just not really working when it comes to safety. It may be working with respect to making money. Even there, the only person really making money is Jensen Huang and his, his company, NVIDIA, right? Selling chips. But, the analogy, which many people have used at this point, is it's like selling shovels in the gold rush. Jensen's selling the shovels. He makes a great shovel. They work really well. There's a wonderful ecosystem around them. He's a great manager. The company, everything about the company is great. But the problem is that the people buying this stuff don't actually know how to make money from it. None of them, or almost none of them, have actually made any profits. And that's partly because the stuff is unreliable.
So do you see it just continuing like this, or are we going to hit a wall somewhere, or have we hit a wall?
Well, I wrote a paper in 2022 saying deep learning is hitting a wall. And the point of it was that we couldn't just keep scaling pre-training data. And in fact, that is proven to be correct. Part of the argument was not that we would make no progress at all, but that we would keep running into the same problems, which were hallucinations and problems with reasoning and misuse for misinformation and so forth. And we're still seeing those same obstacles. Maybe I chose the wrong metaphor there because you can always say, well, I made progress over here. But the fact is, on the critical dimensions of how you would make things like reliable agents, we have not made that much progress.
And I mean, I spoke to someone who promised AGI this year. What's your take on AGI?
For when?
Yeah, or like, is it going to ever happen? Or is it reality? Is it just...
It'll happen. There's no principled reason. It's really an architectural problem. We have the wrong architecture, and we don't know how long it will take to find the right architecture. It's very unlikely that we're going to see AGI in the next couple of years just by doing more of the same. It's just not really working. I mean, it works a bit, but it's not really getting us to AGI. It's possible we could get there in 5 years. It's a relatively long time with this many people doing research and so forth. It's more likely we get there in 10 years, and, it's very likely we'll get there in 100 years, but we don't know exactly when.
I'm just going to say, I heard Google talk about something slightly different to that.
I don't think it was Google. I think it was actually Mustafa at who is now at Microsoft. But
okay,
I actually talked about a very similar idea a long time ago, which was pointillistic AI, I think like 5 years ago. And then Ethan Mollick turned it to jagged intelligence. And then I think Mustafa borrowed it. Nobody getting attribution along the line. But the idea is that these systems get problems that are, well, my version of the idea is they get problems that are close to what they've been trained on, but you move further away and they're less reliable. And so they are jagged or pointillistic in the sense of like they get some of the points, but not others. And you don't really know in advance whether it's going to work. And one of the insane things about this current era is compare it to the era of calculators and spreadsheets. Calculators and spreadsheets, if you pose the problem correctly, you will get a correct answer. Now, of course, you can leave something out in a spreadsheet. Your formula can be wrong. That's on you, right? It's not on the system. Excel will calculate what you tell it to calculate. My pocket calculator, will tell you. A slide rule never hallucinated, not once. I was too young to use them much, but I did learn how to use them. That is not true of this class of AI products. It's also, not necessary for all AI. So GPS systems don't invent streets. We're here on the Vegas Strip. They don't make an alternate version of the street that goes like the Lombard Street in San Francisco crookedly. I mean, they just don't do that.
Yep, exactly.
Right. Classical AI does not make stuff up, and we're steeped in this crazy paradigm where we're pretending, like winking, hey, we don't mind if we just make stuff up. But it can't last.
Yeah, because that's my next question is like, where do you see this going in the next few years? Just more money thrown at it? What do you think is going to happen? What's your predictions? I mean, the most famous stock advice that I ever got, and I don't really play the market, was the market can stay irrational longer than you can remain solvent. So, why am I not shorting all of this stuff? It's because I don't know how long the delusions will last, right? I mean, you could have looked at tulips and said, back in the day and said, this is insane. But you don't know when people are going to stop, spending $7,000 on one tulip or whatever. And so it's hard from the outside to know that. In fact, if you look at my track record of predictions on technical stuff, I've been damn near perfect. I've been really, really good. On irrationality of the market, I've been not so good. So I didn't think OpenAI was going to get to a $300 billion valuation. I was wrong about that. I don't think it deserves it, but it's much harder to predict what how other people are going to believe the marketing hype and whatever. And so I don't know. One possible outcome is people look today at GPT-5 and they're like, fuck, that is not AGI. Sam has been telling us we know how to build AGI for years. This just isn't AGI. It's nice. It's handy. I'm glad it's cheaper. I'll use it. But it's not AGI. We're not going to get to AGI next year. Probably not going to, save as much money for various workplaces as we thought. Maybe it doesn't make sense to put in all this money. And tomorrow, NVIDIA could crash. People could look at that and say, this was a really disappointing thing. But they probably won't. They'll probably just be like, okay, let's buy some, people are going to use this. Let's sell more chips. And I can't predict the human psychology. And it's really the mass psychology part of how long people are going to stick to this bet. At some point, they have to stop doing it. I mean, you can't just do what Elon just did and you 100x every time your investment. So I think, I might be getting my numbers wrong, but I think Grok 4 is 100 times the size of Grok 2. So what is Grok 6 going to be 10,000 times as big? We don't have enough power and water on the planet to fuel it. At some point, this has to run out, but I don't know what day that's going to be. And technically, what do you think?
Technically?
Technically, yeah. You say you bet at the technical predictions?
Oh, I mean, I've made many. So I predicted that hallucinations wouldn't go anywhere. I predicted that GPT-5 would take much longer than people thought that it would, and it did. I predicted that, reasoning errors would not be solved immediately, and they didn't. I have a an essay people can read called 25 Predictions for 2025.
Okay, great.
And they're almost all on target. I think like 22 of them or 21 of them are on target so far. And that reviews also some of the earlier predictions I made. Like I predicted that there wouldn't be much technical moat because there would be diminishing returns because everybody would sort of converge on roughly the same place, and that has happened. So, there have been many predictions that have been correct over the years.
It was one prediction, one technical prediction that because people might not have read that.
Well, I mean, the one that I made that I'm in some ways most proud of is 25 years of predicting that hallucinations are not going to go away if you just use this kind of. It's I've been correct for a quarter century on that, and to be correct for a quarter century in AI is a pretty remarkable thing.
Gary, thanks so much. We're out of time. I'm getting chased. Any last words before we wrap up?
Well, those of you who are watching this in the cybersecurity world, you have to pay enormous attention to prompt injection attacks. They're going to, I think, ultimately eclipse everything else you've ever dealt with. Everything you know and have learned about is going to be helpful, but this is going to be a massive problem. We're going to need all hands on deck. It's going to be really huge.
Gary, thanks so much.
Thank you.
Thanks a lot, man. Appreciate it.